So this video will focus on section 3.3, which is on ionic compound. So we saw that an ionic bond is formed when a metal transfers one or more electrons to a non-metal. So ionic bonds happen between metals and non-metals. And because metals like to lose electrons and non-metals like to gain electrons, then what happens is that the metal transfer one or more electrons to the non-metals. And so this way they become cations and anions. And then there is a strong electrostatic attraction and they bind. And so the sum of the charges in an ionic compound must be zero overall. And that's really the driving concept that will allow you to write formulas for ionic compound. So let's look at sodium and chlorine. Sodium is a metal from group 1A, an alkali metal that has only one valence electron. Sodium likes to lose that valence electron. And if there is a chlorine around, chlorine is a non-metal from group 7A. It's an halogen that has 7 valence electrons. And chlorine likes to gain an electron to get 8 valence electrons around it. So then there is a transfer of electron from sodium to chlorine. And so the sodium will become Na+ from losing an electron. And the chlorine will become Cl- from gaining an electron. And so they each have one, so sodium has one positive charge, chlorine has one negative charge. And so this positive charge and that negative charge, they cancel each other. And when they're together, Na and Cl, it is a neutral formula. And so that's how table salt, the NaCl sodium chloride compound is formed. And so ionic compounds are mostly crystalline solid that we also call salts. It doesn't refers to table salt. When we talk about salts in chemistry, it means all these ionic compounds that form crystals solid. So, and the NaCl in particular is forming a solid where for each chlorine you have a sodium around, and so they form a cubic shape like that. And you can see how it's packed together and it's ordered. So that's what solid typically looks like at the atomic level. Let's look at another example of ionic compound. Let's have a magnesium, Mg, and chlorine together now. So magnesium is an alkaline earth metal from group 2A, so has 2 valence electrons. And magnesium likes to lose those 2 valence electrons to get, 10 electrons around it instead of 12, to be like a neon. And chlorine, we know already, likes to gain 1 electron because it has 7 electrons already from being in group 7A, has 7 valence electrons, likes to gain 1 more to have an octet. And so when you have magnesium combining with chlorine, magnesium will lose 2 electrons, but 1 chlorine will take only 1 electron. So you need another chlorine to take the other electron given by magnesium. So the magnesium becomes magnesium 2+, and then you have 2 chloride ions. So for each magnesium, you need 2 chloride ions. And so you see now that we have 1 magnesium 2+ ion and 2 chloride ions. And so the magnesium brings 2 positive charges, and the chlorine, they each bring 1 negative charge, but there is 2 chlorine. So in total, it's 2 negative charges. And so the 2 positive charges from the magnesium are cancelled out by the 2 negative charges from the 2 chlorine. And so together, this will be a neutral compound. And so that's how we will find the formula for magnesium chloride, is by seeing that we need 2 chlorine for 1 magnesium. And so the formula is written always by writing the positive ion first, the metal first, so magnesium first, and then chlorine. And the little 2 in the lower right corner is written in subscript. And so the subscript in an ionic compound represent the lowest number of positive and negative ions that give an overall charge of 0. So here, this formula MgCl2 is neutral because the 2 plus charges from magnesium cancels the 2 negative charges from chlorine. And so we need the 2 as a subscript for chlorine. So how to write a formula for an ionic compound? So let's go through an example to make it easier to see how to do this. And the example we will use is the formula for the compound formed between aluminum and oxygen. So the first step is to identify which element is the cation and which element is the anion. So write the symbols of the ions first. So here we have aluminum. So you want to find aluminum in the periodic table. Aluminum is in group 3A. Its atomic number is 13. Aluminum is a metal. It's right below the staircase line. We know that it's not a metalloid, it's a metal. And it's in group 3A. And metals in group 3A are predictable ions. You know that metals from group 3A will become 3 plus ions. So the symbol for aluminum is Al3 plus. Oxygen. Oxygen is also in the right side of the periodic table. It's in group 6A. So oxygen has 6 valence electrons and it likes to have an octet. And to get an octet, it needs 2 more electrons. So 8 minus 6 is 2. And oxygen will gain those 2 electrons to get 8 around it. So it's going to be oxygen -2 ion. So you write the positive ion first and then the negative ion second. The formulas, they always start with the positive ions, which are the metals. So metals first and non-metals second, just like they show up in the periodic table. And so to determine how many of each ions we need to make a neutral formula, we have a trick, and it's called the criss-cross trick. The criss-cross trick uses the charges of the ions and they will become the subscript for the other ion. So it looks like this. You crisscross the arrows and one arrow shows that the 2 from the -2 charges of oxygen will become the subscript for aluminum, and the 3 from the 3 plus charges for aluminum will become a subscript for oxygen. And so to write the formula, place the cation first, then the anion, and omit the charges. Use subscripts to show the number of each ion needed to have a 0 overall charge. So the criss-cross trick shows that it's Al2, O3. The 2 came from the 2 minus from oxygen, and the 3 came from the 3 plus from aluminum. But they exchange, and now there are no more charges, they have become subscript. And you remove the plus and the minus, they should disappear because the overall formula of an ionic compound is neutral, and we don't want any positive or negative sign showing up anymore. So you want to make sure this formula is neutral, and so we will count the number of positive charges coming from aluminum. Aluminum, there is 2 of them, and they each carry 3 positive charges. So 2 times 3 pluses, it's 6 positive charges in total. Now let's count the negative charges. So they come from oxygen. We have 3 oxygens. They each carry 2 negative charges. So you do 3 times 2 negative charges, and that's 6 negative charges in total. And so 6 positive charges will be cancelled by 6 negative charges. And so this formula, Al2O3, is neutral. And so we know it's correct. So here it's a slide detailing what is the criss-cross rule. The criss-cross rule means that you make the magnitude of the charge on one ion into a subscript for the other ion. And so when doing this, make sure that subscripts are reduced to the lowest whole number ratios possible. So let's look at another example. The compound made from magnesium and oxygen. Magnesium is a 2+ ion because it's coming from group 2A. It's a metal from 2A, so it's a 2+ ion. Oxygen being from group 6A, 6 minus 8 is -2. Oxygen is a -2 ion. And so if you crisscross the charges, it's 2 as a subscript for magnesium, and also 2 as a subscript for oxygen. So the formula should be Mg2O2. However, because it's 2 for both, that means the ratio is really 1:1. You need 1 magnesium for 1 oxygen ion to cancel the charges. And you can see that very well by looking at the 2 ions. The 2+ from the magnesium should cancel the 2- from the oxygen. So you really need 1 of each only. So it is important to check that the ratio of your subscript is the lowest ratio possible for the subscripts. And so 2 and 2 become 1 and 1. And the ones are implied. We do not write them. They are implied. So the formula for the magnesium oxide ionic compound is MgO. So let's go through some learning checks. For this, we will practice by writing the formula for the compound called lithium nitride. It's a compound containing lithium and nitrogen. Pause the video to work this out on your own before you watch the answer. So lithium is a metal, alkali metal from group 1A. So being from group 1A means it's going to be a +1 ion. It's a predictable ion. Nitrogen is a non-metal on the right side of the periodic table in group 5A. You do 8 minus 5, it's 3. And so non-metals become negative ions. And 5 indicates that it needs 3 more electrons to have 8, an octet. So nitrogen becomes an N-3 when it's an ion. Now you would write lithium first and then the nitride ion second. And you can do the criss-cross trick And so the 3 from the nitride ion can become a subscript for lithium, and the 1 from the lithium will become a subscript for nitrogen. And so the formula is Li3N. And you can also verify that this is correct by checking that you cancel all charges. So we have 3 lithium plus. So the 3 as a subscript after lithium says it's 3 lithium. Lithium carries 1 positive charge. So it's 3 positive charges in total. And you have 1 nitride ion with 3 negative charges. So 1 nitride with 3 negative charges, that means it's 3 negative charges in total. So 3 positive charges are cancelled by the 3 negative charges, and the formula is neutral. And that's how we know this formula for lithium nitride is the formula, the correct formula, Li3N. Let's go through another example. We want to write the formula for the compound containing barium and chlorine. So pause the video, work this on your own before watching the answer. Barium is metal from group 2A. It's an alkaline earth metal from group 2A. So it will be a 2+ ion. It's a predictable ion. Chlorine, found in the right side of the periodic table in group 7A. It's an halogen. Halogens have 7 valence electrons, and they need 1 more electron to be like the next noble gas. So they like to become -1 ions. So chlorine, a nonmetal from group 7A, forms the Cl- ion. Next, you write the barium first and the chloride second. You want the positive ion first, negative ion second. And you can do the criss-cross trick. So the 1 from the chloride negative charge will become the subscript for barium, and the 2 from the 2+ of barium will become the subscript for chlorine. And so the formula is BaCl2. So let's make sure this is a neutral formula and the correct formula. And so the formula says 1 barium. So 1 barium, and each barium carries a 2+ charge. So that's going to be 2 positive charges in total. And the formula says 2 chlorine, 2 chloride ions with 1 negative charge each. So 2 times 1 negative charge, it's 2 negative charges in total. So the 2 positive charges from barium are cancelled by the 2 negative charges from the 2 chlorines. And this is a neutral formula. So barium Cl2 is the correct formula for barium chloride. One more learning check. So select the correct formula for each of the following ionic compounds. When you're forming a compound between lithium and oxygen, and you're given the ions charges, so here you can just do the criss-cross trick. So the 2 from the negative charges of oxygen become a subscript for lithium, and the 1 from the positive charge of lithium becomes the subscript for oxygen. So that means it is Li2O. And this cannot be simplified. It's the correct answer. You can check by verifying that 2 lithium with 1 positive charge each gives 2 positive charges in total, and 1 oxygen with 2 negative charge each is 2 negative charges in total. So 2 pluses and 2 minuses, they cancel, and Li2O is neutral. Aluminum 3+ and chloride minus. Cl minus. Again, you can do the criss-cross trick. The 3 from the 3 plus of aluminum becomes a subscript for chlorine. And the 1 from the negative charge of chlorine becomes a subscript for aluminum. And so it becomes AlCl3. And that is the correct formula, because you can see that 1 aluminum with 3 positive charges cancels the 3 negative charges coming from the 3 chloride ions, because each chloride ion carries 1 negative charge. Oops. So let's go through the last example here, magnesium and nitride, magnesium 2 plus and nitride 3 minus. You do the criss-cross trick. So the 2 from magnesium 2 plus becomes the subscript for nitrogen, and the 3 from the 3 negative charges of nitrogen become the subscript for magnesium. You crisscross the charge and it becomes magnesium 3N2, Mg3N2. We can verify that 3 magnesium with 2 positive charges each, it's 6 positive charges in total. And 2 nitride with 3 negative charges each, it's 6 negative charges in total. So 6 positive charges cancels 6 negative charges, and Mg3N2 is neutral.